Hello, and welcome to Partially Redacted, a podcast where we discuss data privacy engineering and related topics. I'm your host, Sean Faulkner, and today I'm joined by the Vault product lead of Skyflow, Joe McCarron, and we will be discussing tokenization and encryption. Joe, welcome to the show.
Hi, Sean. Thanks for inviting me on. I'm excited to be a part of this.
Awesome. So obviously, we know each other since we actually work for the same company. But before we dive too deep into our discussion topic today, could you please introduce yourself for anyone out there listening? Who are you and what do you do?
Yeah, sure. Hi, everyone. I'm Joe and I work at Skyflow. So I'm one of the product leads here and I cover primarily our secure storage layer. So that's really kind of where and how the data is stored in our privacy vault. And I also cover our tokenization products as well as our administration experience and the overall developer experience. So everything from docs and SDKs to the actual design of the APIs.
That's a lot of stuff.
It's a lot of stuff. I'm building a team. So, if anyone's out there looking for a product management job in data privacy, give me a call.
All right. Starting with the plugs. So you've worked as a product manager. You've worked as a product manager for a number of years across a number of different companies. Can you talk a little bit about your background in product management?
Yeah, in product management. So I'll go a little bit farther back. So I kind of got started with tech, just doing web development. So in high school, I actually started building websites for different small business clients, and I got really enjoyed the experience of being able to kind of learn about a customer's needs and actually go through the process of creating something to meet those needs. And so I was always really interested in software development. I actually didn't go to school for it, but then after college, I decided I really wanted my career to be in software development. And I started looking around for different roles. And I realized that the product management role just really spoke to me the most, because what I really enjoyed the most about that process was really talking to the customer, learning about their needs and their pain points and trying to find things that even maybe they didn't know how to put to words. And so when I moved out to California and I tried to get into tech, and I actually first took a job in customer support for a company called Zendesk. And I figured that would be the best way one of the best ways into product management, actually being essentially one of the customers using the software to provide customer support to other organizations. And so I learned a lot through that experience. I got to serve a number of different roles at Zendesk over the years, but eventually I made my way into product management, focusing on APIs and developer experiences in particular. And that was an area that has always interested me and still interests me to this day. It's something that I think is a bit of a niche in product management, or has been historically, and is becoming much more front and center for a lot of companies. They're realizing the power of developers and how valuable it can be to really serve that audience.
Yeah, it's interesting with the growth of sort of developer first companies and API first companies that the need for people in product management that have that experience, but there's just not that many of them that actually exist.
Yeah, we're a small tribe out here, but growing.
Yeah. So you mentioned that your college degree wasn't in computer science. What was it in?
It was actually in political science. I studied economics, political science, and then I got a minor in management as well. I've always had a bit of a feel for business too.
Great. So how did you actually end up working in data privacy space? Like, what's your history with working in data privacy?
Yeah. So for that, I'll go a little bit farther back to data privacy has just always been something that's been really kind of interesting to me, or something that I really believed in. As somebody who kind of grew up with the internet, I remember times before the internet, unlike many people now. And I remember kind of learning about, to protect yourself. We were taught as kids that, the internet was a scary place. And so I always was very mindful of, what I put out in public and, what was private. And that's always kind of how I thought about data privacy, was this public versus private, what you put, on social profiles and wherever else that's public to the internet. And over time, I started to kind of get more concerned with not just public versus private, but, what data are you giving to companies, or what data are companies collecting about you that is kept in private? And then, through my career working first at Zendesk and then also at Apollo GraphQL, I got the opportunity to work with a lot of different companies and kind of see the inside of how they manage customer data, a lot of the challenges of collecting, storing, and accessing customer data. And that was in the time before, GDPR and a lot of these privacy policy frameworks. And so watching that shift, that happened while I was at Zendesk. GDPR came out, and I got the opportunity to help a lot of Zendesk customers, really large organizations, rethink how they approach customer data and customer privacy. And what I realized through a lot of that, I mentioned I was in solutions architecture. I got to work beyond the customer support platform and figure out how it fit into the overall sort of data landscape at companies. And I just saw what a challenge it was for companies, not just to make sure that they got the data that they need in the right place, but also to actually implement privacy protections and make sure that people who shouldn't have access to the data don't have access to the data. And that so many of our applications and even our databases are not really built for privacy. And that's when I started to get really interested in privacy engineering specifically.
Mm-hmm. Do you think that there's been, in your time working in technology space for, a number of years, there's been a shift in sort of the philosophy that both companies as well as consumers have taken to their approach and understanding of privacy?
Absolutely. Yeah. I mean, I think, around that time, say, 2015, 2016, I forget when GDPR exactly came out, but I think it was around that time. Companies were not optimizing for data privacy. Storage got really cheap, cloud compute got really cheap, and often you'd see engineering teams optimize for just never deleting data. There's no cost to retaining that data when there's no real privacy risk. But as that privacy risk started to go up, not just because of regulatory frameworks, but because of high-profile breaches, people started to really reconsider, should we be holding this data? It wasn't just a concern of, how much does it cost to store on disk, but how much does it cost us as an organization to open ourselves up to this risk and to have all of this data that in some cases customers might not know you have, and in other cases customers might not want you to retain.
Right. So today, we're talking about a couple of different technologies or techniques that are used often when we talk about like data privacy and data security, which is tokenization and encryption. And just to kind of set the context for those that are listening or maybe less familiar with the data privacy space, what is tokenization?
Yeah, tokenization is a great topic. I always like to take an expansive view of things. And tokenization itself is a concept that's used in a number of different industries and even a number of different sort of domains in computer science. So I'd say tokenization just generally is substitution, essentially. It's substituting one thing for another thing. So it's also used in natural language processing to sort of break down text and substitute tokens. But in the context of privacy, tokenization serves, the purpose of tokenization is isolation. It's about minimizing the surface area, essentially, of your sensitive data. So tokenization practically just allows you to swap a sensitive value, some sensitive data point, whether that's an email address, a social security number, a credit card number, really anything, for a non-sensitive value. So that's often it's randomly generated. Sometimes it's not randomly generated. We can get into the nuances of how tokenization actually works, but the benefit of it is that isolation of sensitive data. So rather than allowing sensitive data to proliferate all over your different systems, when you talk to large organizations, sometimes they have 100 different microservices and 20 SaaS apps and thousands of employees with their own machines. That sensitive data can end up in all of those different places. And so really key to proper privacy engineering and privacy by design is really isolating the sensitive data and minimizing the surface area for where it can be accessed.
Mm-hmm. And then how does the company go about actually like performing that process? Obviously, a company that is trying to solve this problem today, they have that proliferation of data all over the place. So how do they actually kind of, walk that back from having all that replication happening to using something like tokenization?
Yeah, I think it's something that a lot of companies are still working through or still trying to figure out. And it's not, there's not one solution that solves the problem for everyone. But I think principally you want to tokenize, you want to isolate the data as early as possible from when it's collected, when it's gathered. Because as soon as it gets into one system, often it gets replicated into other systems. So you really want to get it at the point of ingress and substitute sensitive values for tokens, for non-sensitive tokens, so that all of the downstream systems by default do not have access to the sensitive data unless they specifically need access to it for some reason. Then sometimes you would still tokenize it and just allow them to look up using the token. But it's all about really catching it as early as possible.
Mm-hmm. And you mentioned that there's a lot of nuances in terms of different types of tokenization. Can you talk a little bit about what some of those nuances are, the different approaches to tokenization?
Yeah, absolutely. Tokenization, I would say tokenization really started to gain traction with companies, particularly banks, but financial institutions that were all operating under the PCI framework and needed to achieve PCI compliance. So a lot of the early tokenization solutions were focused on credit card numbers because that's the most sensitive information, in terms of PCI compliance. So a lot of them were pretty simple. They just allowed substitution of a credit card number with often something that looked like a credit card number. So that's one aspect of tokenization is what does the actual token look like? Does it look like a credit card number or does it look like some totally random, UUID string? So that's one of the choices that any developer, any organization that's trying to adopt tokenization needs to make is what does the end product, what does that token need to look like? And often that's determined by the downstream systems, right? So if you've got a bunch of systems that are all expecting something to be formatted as an email address and will reject it if it's not an email address, what we call format preserving tokenization is really useful because while it's not an actual email address, while it's not a sensitive value, we generate a token that looks like an email address so that all of the downstream systems will accept it. So that's one big choice that organizations and developers face when adopting tokenization. Some of the more nuanced aspects of tokenization are in the generation of that token. Do you want that token to be used across different records? Do you want it to be essentially a relationship or a lookup value? So that's another choice that customers face. Skyflow customers or just any organization implementing tokenization is, do you want these values to match across columns, for example? And so that's something that we call deterministic tokenization. The industry has a few different terms for it, but that's something that we've been using. And so the idea is that the same input value, say the same credit card number, would generate the same token every time. And that's something that has a lot of implications. If somebody gains access to that data set and you have these deterministic tokens that match across columns, even if they don't know what that value is, say what your email address is, they might know that both of these records have that same email address, so they can start to deduce some more information from it. So the most secure way to do tokenization is to use completely random tokens. So every time you submit a value, you get a different token. So even if some attacker gets access to your database, they see an email column in one table and an email column in another table, they can't actually cross-reference those. They can't tie those records together.
Right. So it sounds like through something like deterministic tokens or even some of the format preserving tokens, you're maybe potentially leaking or some information by using one of those approaches. But the trade-off is utility, essentially, where you're still supporting your downstream services or supporting other types of workloads where it makes sense.
Yeah, exactly. And, putting a security hat on, utility on one side is also utility for any attacker, right? And so you need to balance those trade-offs.
Right. And then the other, topic or other technology that we are talking about today is encryption. And can you talk a little bit sort of high level about, I think most people working in technology space have some concept of like what encryption is, but do you want to talk sort of broad strokes of what encryption is, and maybe specifically to sort of the data privacy space?
Yeah, sure. So yeah, as you mentioned, everybody has some idea. I imagine everyone listening to this podcast has some idea of what encryption is, but in comparison or in relation to tokenization, I like to think of tokenization as focused on isolating that sensitive data, that data that you need to secure. But when you isolate all of your valuables, put everything valuable in your house into a closet, that's great because now there's just one place that you need to protect. But how do you actually protect it there? And that's where encryption comes in. Encryption is kind of the lock that you put on the data. And so encryption basically allows you to secure data using keys. And so in combination, tokenization and encryption allow you to both centralize the data in one place, limit the number of people that have the keys, and then lock it down tightly using encryption.
Pardon the interruption, but it's me, Sean, the host, talking to you directly. I hope you're enjoying the episode, and if so, please subscribe and leave a positive rating and review. You can also join the partially redacted community at skyflow.com/community to make show suggestions, interact with me, other listeners, and privacy experts and enthusiasts. All right, now back to the show. Yeah, I love that analogy of putting everything in your closet, and then you need to lock it up if you want it to actually be secure.
Yeah, exactly.
So it sounds like they're essentially complementary technologies. In terms of the trade-off of if you're only using encryption from like a data privacy standpoint, what is the trade-off of making that decision versus using the combination of tokenization and encryption?
Yeah, so I think that's a great question and something that probably a lot of organizations face, right? When we think about security, we often just think about encryption, right? As long as the data is encrypted, nobody can get it. But if you don't take that step to isolate the sensitive data to minimize the surface area, you end up with a number of different problems, really depending on how you approach it. Often what we see at large organizations is that the sensitive data is spread out across a bunch of different data stores, so different databases, analytical databases, operational databases. It's in a lot of different places. And so one, that makes it hard to keep track of. It's hard to know, who accessed this data. You have to gather logs across a bunch of different systems. It's hard to keep track of keys. If you have this data in a bunch of different systems, there's a bunch of different keys. Only one of those keys really needs to be compromised for somebody to get access to sensitive data. So the more keys you have, and really the more doors you have, the number of systems that you put the data in, the more risk you have. And honestly, just the more complexity you have in managing it and proving compliance. Because a big part of compliance is also, all of the processes and audits to make sure that who is accessing the sensitive data.
Right. What in terms of the types of encryption algorithms and techniques that are used in the data privacy space, what are the typical types of encryption techniques that people would encounter in the space?
Yeah. So with encryption, I won't get into different encryption algorithms, but in terms of approaches to encryption, one thing that I think a lot of people fail to recognize is that encryption happens at multiple different layers, right? And so a lot of organizations will have already implemented some form of encryption at rest. And so that's the data when it sits in the database. The entire database itself is essentially encrypted. But anytime you need to access that data, you need to decrypt the database. You need to open that lock. Yeah, so encryption at rest is essentially putting a lock on, encrypting the entire database together. But anytime you need to access the data in that database, you need to decrypt it. And so often what we see, in the security world, we've seen a huge rise in attacks on the actual memory. So the application is decrypting that database, it's holding that database in memory, and all of that is essentially unclear in the memory. And so an attacker can go in and they can dump the memory and they can gain access to all of that sensitive data. So you have encryption at rest. You also have encryption, table level encryption. So sometimes that is just each table has a separate key and is encrypted. Sometimes you have column level encryption where each column gets a different key and gets encrypted separately. But where we really see the value is in encrypting at all of those layers. So encryption at rest, database level encryption, and even encrypted operations is something that I think is starting to gain a lot of traction in the market and be a really valuable solution to anyone who needs to secure data and prevent these sort of memory attacks.
Right. So the idea behind the encrypted operations essentially is, the problem with, I guess, encryption is, or the downside of encryption is you have to decrypt it to use the information. But if you can do operations over the encrypted data, then you don't have that downside.
Right. It all goes back to that idea of, when you lock up the data, that's great that it's locked up, but if you're giving out the key to everyone, if it has to be, opened to use anything in that closet or in that vault, you're decreasing the security. The more times that door needs to be opened, the less secure it is.
Mm-hmm. Yeah. And, going back to the idea of tokenization, where you're essentially storing these tokens downstream, can you talk a little bit about how someone actually uses the tokens to do, simple operations like show someone's record on a web UI, or send information to a third party system? If they only have access to the tokens, like how do they actually perform the utility that storing the plain text values gives the company?
Yeah, sure. So, one of the kind of metaphors that people often use with tokenization is that of a coat check. I don't know if you've heard that one, but that was always one that I found kind of simple and interesting, which is that, with a coat check, you've got your valuable coat, you go and hand it to someone and they hand you a little ticket back. Whenever you need your coat back, you just go back, you hand them the ticket, you get your coat back. And so that's kind of a really simplistic way to think about tokenization. And so what we were talking about earlier is that basically as soon as the data hits your systems, you want to swap it out, you want to put it in the coat check, and you want to replace it with that ticket. And so then whenever you need to access it, you actually need to hand that ticket off to the tokenization service and get that piece of data back. So there's a number of different ways that people do that. Generally, or at least the sort of modern approach, is just through APIs, right? You need to have performant APIs that are integrated in all of the systems that need to access that sensitive data, and they pass that token and they get back the sensitive data. But where I think the coat check metaphor falls down, and this is actually a reason why I've started kind of shifting away from that, is that a coat check isn't actually, they just check that you have the ticket, right? If you get somebody else's ticket, you could probably walk up, hand it to the coat check, and get their coat back. So a true tokenization solution, and this is where they start to get more complex and more powerful these days, is it has a layer of governance on top of it. It has authentication so that you actually prove who you are, and it has authorization to prove not only who you are, but that you have a right to access that piece of data. And then, for full compliance, a modern tokenization solution also keeps a full log of everyone who's accessed the data, sometimes even the purpose for accessing that data, sometimes the time period for accessing that data, just a really complete record of who, how, and why that data was accessed.
Right. Yeah. I mean, it sounds like with tokenization or any of these sort of privacy preserving technologies, the technology in isolation is not a full solution. You really need to sort of combine it with a bunch of other approaches to get to a place where you're compliant, as well as doing your best in terms of best practices around data security.
Yeah, exactly. It's not just tokenization. And I think a lot of organizations have kind of fallen into that trap, because tokenization on its surface, it sounds really easy. It's not like encryption. I don't think most engineers, when they think about encryption or they have a problem that requires encryption, are going to go write their own encryption algorithm. Right.
Right. We hope not, anyway.
Yeah, we hope not. I think most people are smart enough to know that the NSA is probably a little bit better at writing encryption algorithms than your average developer. But with tokenization, it seems so simple because when you first read about tokenization, it's not talking about complex math to transform data in irreversible ways. It's just talking about you substitute this thing with this thing. So I think a lot of organizations have ended up building their own tokenization solution that simply generates a random string and then sticks something in a database. But without that advanced access control, without all of that auditing, without strong authentication, a tokenization solution is just putting all of your valuables in one closet.
Yeah, it kind of reminds me of, there was a time when everyone rolled their own authentication and you considered that like a really simple thing. And then Auth0 came along and you're like, and showed everyone how, complicated that actually gets. And then now, most people don't do that because they recognize that it doesn't make sense to, because there's a lot of layers of the onion of authentication that you don't want to take on all that complexity.
Yeah, exactly. It's actually a pretty deep topic to get into.
Yeah. So in terms of, your typical engineer today, that's, maybe a full stack engineer, how much do they really need to kind of understand about concepts like encryption and tokenization?
Yeah, it's a great question. Honestly, I think encryption and tokenization are like really any other deep technical topic. You really only need to know as much as you need to know to get the job done. And so, going back to what we were just saying, sure, if you want to build your own tokenization solution, you're going to need to learn a lot. You need to become a domain expert in this field. But I think most engineers don't need to necessarily go that deep and don't need to build their own tokenization solution. I think, over my time working in software, some of the most effective engineers that I've ever worked with, the one thing that they share is that they know when to build and they know when to just use something off the shelf, whether that's, for example, if I was talking to an engineer about building an API and they came back to me and said, I'm not sold on this REST idea or this GraphQL idea, I'm going to come up with my own way of doing APIs. That would be a bit of a red flag. And I think tokenization and encryption definitely, and tokenization is getting to the point where engineers know to kind of trust best practices and trust kind of standard solutions. And so you really need to focus on kind of the benefits and what you're really trying to achieve. Because like we talked about with the trade-offs of the different types of tokens that you can generate, you need to understand really the implications for all of the downstream systems, for all of the consumers. So you need to focus on kind of what your goals are, what outcomes you're trying to achieve, and then understand the trade-offs of the different approaches that are available. I would not recommend, coming up with a new tokenization or encryption approach.
Yeah, I think that's really, well said. I think I see these things as, they're kind of building blocks to an existing system today that you're trying to build in a, compliant and data secure way. And similar to, building blocks of, modern programming language where you're going to utilize data structures and algorithms that are built in the language, and you kind of need to know when to use them, how they're structured, but you don't necessarily need to be able to build like a red-black tree from scratch or roll your own sort of balanced tree from scratch, because you can rely on these sort of existing systems and you kind of just need to know enough to how to utilize them.
Right. Yeah. Right. It's something that, while it can be fun to reinvent the wheel, it's not going to be the most effective way to accomplish your goals and build what you're trying to build. The more things you can take off the shelf. One thing, I've worked in platform product management for a long time, and I've given some talks about kind of what that means in the sort of modern developer ecosystem. One of the metaphors that I really like to use when talking about that is cars. I'm a car nerd personally, and a lot of people don't know this, but like most of the auto manufacturers, they don't build all of their parts. They buy wheels and they buy alternators, and sometimes they even buy whole engines. They're not going to design and build everything themselves, because it's just not an effective way to operate and an effective way to build things. There are people who specialize in different fields. You can buy from them, you can borrow from them, you can learn from them, and you can go much faster.
Yeah, that's great. That's a great analogy. Looking beyond tokenization and encryption, are there sort of big gaps in data privacy today, and what future technologies and developments are you perhaps excited about?
Yeah, I think we're at the beginning of this data privacy journey. Like I talked about, GDPR and some of these privacy laws came out a few years ago and really changed everything. But we haven't even caught up to where the regulations are. I think most people working in software know that often we're meeting compliance requirements specifically, but we're not going so far as to actually meet customer expectations and what customers really demand. I think that's where the biggest opportunity, and that's why this space is really exciting to me, is because first of all, it's not a simple problem to solve. And second, the actual, how companies actually handle customer data, I think is so different from what many customers, at least the privacy conscious customers, really expect. And so while we've started to solve for data privacy in sort of the payment space and the health tech space, I think the broader consumer space has a really long ways to go. And we've secured data in our primary systems, but there's so many downstream systems. There's so many places where customer data ends up that we're really just at the beginning of this journey of real privacy engineering and privacy by design. So many of the companies that operate today were built, not only the company, but the software was built before data privacy was really a concern. And so a lot of those companies are playing catch up. And what I'm really excited to see is kind of the new generation of startups that have been built with privacy in mind, with privacy as a core goal. We're starting to see more and more of those. And I think those companies are going to be really successful over the next 5-10 years, especially as new privacy legislation comes down. Just as we're at the beginning of privacy engineering, I think we're at the beginning of privacy legislation too. Like Europe has been leading the way, the EU has been leading the way. Certain states in the US are playing catch up, and we're looking at the potential for a federal privacy framework, federal privacy legislation in the US. So I think the landscape is going to continue to shift pretty rapidly over the next few years.
Yeah, and all those things are going to have a significant impact on existing businesses and also on the way that people engineer and architect systems.
Yeah, absolutely. It's going to change software engineering. It's going to change company processes. It's going to change customer expectations. Like this whole industry is going to shift in some way. Really just depends on kind of where you sit.
Yeah, so I think, there's a lot of things that are exciting going on in the privacy space. And, one of the things I'm really excited about is you're starting to actually see in sort of general software engineering conferences, privacy tracks. It's kind of similar shift that happened with security where, in the last 5 years, security tracks started to show up in general engineering conferences. And now you have privacy showing up in general engineering conferences. So beyond sort of some of the things that we discussed in terms of the gaps in privacy and future technologies, is there anything else you want to share at this time? I know you already plugged that you're hiring, so maybe you want to reiterate that as well.
Yeah, well, if you're interested in privacy, I think it's a great kind of field or domain to get into just generally, whether it's at Skyflow or elsewhere. It's definitely a growing field, a growing industry. And yeah, I would say if it interests you at all, get into it, especially if you're interested in kind of the intersection between code and law. That's something that, I mentioned I studied political science. So this is a space that's really interesting to me. A lot of the most interesting experiences that I had were actually trying to essentially translate between lawyers and engineers, because laws were written. One of the more interesting things I think about privacy legislation is that it's almost written in a vacuum by people who don't understand how computers and modern software works. And so there's a lot of work to be done in sort of working backwards from legal language into actual code, actual system design. And so it's really an unsolved problem. And I would encourage anyone who's interested at all to start, reading up a little bit more, have a look on YouTube. There's a bunch of great books out there about privacy engineering and privacy by design. Dig into it a little bit more, and there's a lot of great opportunities. One of the engineers that I worked with on GDPR at Zendesk, for example, basically went on to make that his career, where now he is taking that knowledge and going to other companies and helping them implement privacy practices. You see that with a lot of privacy professionals. And so, yeah, if it's interesting to you, definitely dig in because it's not going anywhere.
Yeah, that's awesome. I think I've seen that as well. Someone who builds up expertise at one company. And the reality is companies are just, starving for people who have sort of this domain expertise of understanding the technical side of things, as well as some of the, legal landscape. And then what are the sort of technical systems that you need to implement in order to actually implement something like, privacy by design or privacy engineering.
Yeah, it honestly feels a little bit like the kind of API first landscape did maybe 10 years ago. Where there's a few companies popping up in this space, but the demand vastly outpaces the number of people who actually have experience. So it's a good time to get in.
Yeah, awesome. Well, thanks so much for coming on the show and for sharing your expertise on tokenization and encryption.
Thanks, Sean. It's been a pleasure.
Awesome. Thank you.